Okay, let's have a look at this E Fields MCQ question. Okay, there's a small positive charge P balanced halfway between two horizontal plates when the plates have a potential difference of V applied between them. Okay, when V is increased, P rises towards the upper plate. When V is decreased, P falls towards the lower plate. So before we look at these ideas, right, let's have a look at what situation we have. We have a positive charge balanced halfway, means to say that it's in equilibrium. Right, for a charge P to be in equilibrium, there must be forces that cancel out acting on P. Right, so if this is horizontal plates, it means that the weight acting on P must be downwards. Right, so the weight of P must act downwards. And for P to be in equilibrium, there must be an electrical force outwards. Right, so since P is a positive charge, I will conclude that for the electrical force to act outwards, the top plate must be more negative than the bottom plate. Right, so if I were to imagine it visually, I should imagine some negative charges on the top plate. Right, that's why P is attracted to the top plate. Right, and that's why we have electrical charge outwards. Right, so that's what this is about. We know that the top plate is of a lower potential versus the bottom plate. Okay, what does a lower potential mean? It means that if the top plate is 0 volts, then the bottom plate must be 10 volts or 5 volts or some number bigger than 0. Okay, so when we are asked which of the statements is correct, okay, decreasing V decreases both electrical and gravitational potential energy of the particle. Alright, so according to the question, we can see what happens when we decrease V. When V is decreased, P falls towards the lower plate. Right, so P's displacement will be down. ES. Right, so what happens when P moves downwards? Okay, firstly, we know that for gravitation, it's very clear cut. Right, when something moves closer to the Earth's center, GPE obviously decreases. Okay, whether you look at the equation GPE equals to minus GM over GMM over R, right? Because the R value decreases, this magnitude gets bigger, right? So a negative bigger magnitude means I actually get smaller, or the GPE gets to a smaller value, alright? Or you can just think intuitively in terms of what happens to you in daily life. If you go from the second floor to the first floor, right, you get closer to the Earth center, your GPE decreases, right? The same concept applies here. So I know that according to what's given in the question, that when I decrease V, right, according to the question, P falls towards the lower plate. So I know that the GPE must drop. Okay, so GPE definitely drops when V decreases. Okay, what about electric potential energy? Right, having realized that the bottom plate is more positive than the top plate, we can start to draw equipotential lines to visualize what happens to the charge as I move from the center to a lower position. Alright, so what happens is I can do a little bit of hypothetical mathematics here. I know the top plate is is of a lower potential than the bottom plate, so I just assign convenient values minus 5 and 5. Right, what this gives me is that at the middle, right, there's an equipotential line that gives me 0 volts. Right, so if the middle is 0 volts and this is 5 volts, the next middle line between this midpoint as well as the bottom plate will be 2.5 volts. Alright, so maybe I make it clear this positive 2.5 volts. Right, so go from 0 to 2.5 to 5. And further, we can further stretch the idea to make this minus 2.5. Alright, so let's check what happens to EPE. Right, what's the EPE at this position? Right, you should know how EPE is related to potential. Right, EPE equals to charge times potential. Right, so if this is 0 volts, right, if this position originally is 0 volts, the EPE of this positive charge at this position will be 0, right, because it's Q times V. The Q is the Q of the positive charge, the V is actually 0, so my EPE at this position, where the charge is at this position, is 0. Alright, when I look at the position when I drop to a level which I call positive 2.5, the EPA will be given by Q times 2.5. If you give me some positive value because Q is actually positive. Right? Remember when we sub charges for EPE as well as potential, we should sub with the sign of the charge inside. Alright, so actually this charge sign is important. I know it's positive as given in the question. That's why I know the final answer for EPE here at this position is positive. Right, so when we compare what happens to the change in EPE is actually just final minus initial. So I take this value minus this value, which will give me some positive value. Alright, so I conclude that the change in EPE is positive. Or in other words, I can say that my EPE, this leads me to conclude that my EPE increases. Alright, so EPE increases, and you can see why A is wrong now. Alright, A says that EPE also decreases. Right, the GPE decrease part is correct because we already talked about it earlier, but the EPE decrease part is wrong. Right, we concluded that EPE actually increases. Right, so we have the answer actually to be B. Right, because B says that when I move down, my EPE increase, which we just concluded to be true, and my GPE decreases. Again, we concluded to be true. Alright, you can use this idea to go and check C and D. Okay, but I just want to do a little bit of a further discussion. Now, what if I didn't choose this to be minus 5 and 5, instead I choose it to be 0 and 10? Right, as long as this is higher potential than this, that's fine, right? It fulfills the criteria of what we discussed in the question. The top plate must be of a lower potential than the bottom plate. Or in other words, the top plate should be negative with respect to the bottom plate. Alright, so if we were to choose 0 and 10 instead, the midpoint would be 5, this would be 7.5. Alright, so if I find EPE here, it will be Q times 5. If I find EPE here, it will be Q times 7.5. Again, we take final minus initial, 7.5Q minus 5Q, I'll get 2.5Q. And we also remember Q is a positive charge. So again, the change in EPE is still positive. Alright, so I hope you can also see from this question that actually the absolute values of potential is not that important. Right, I just need to know, is this line higher potential than this line or not? Right, that's the key part in solving questions.